Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Classical Dynamics of Particles and Systems by Stephen T. Thornton and Jerry B. Marion. Okay. Classical dynamics of particles and systems by Stephen T. Thornton and Andrew Rex. Oh, sorry, not Andrew Rex. Stephen T. Thornton. Actually, a book Modern Physics has been written by Stephen T. Thornton and Andrew Rex, but this is not modern physics. This is classical dynamics of particles and systems. Here with Stephen T. Thornton, co-author is Jerry B. Marion. Okay, not Andrew Rex. As usual, we first come to its statement. Okay. A spacecraft in an orbit about Earth has the speed of 10,160 meter per second at a perigee. What is perigee? We will see later in this problem. Okay, at a perigee of 6,680 kilometer from Earth's center. What speed does the spacecraft have at apogee of 42,200 kilometer? Okay, dear students, here two terms have been used with which we are not familiar in the ordinary course of business, in ordinary daily life. Okay, one is perigee or perigee and the other is apogee. We will see it later in this problem with the help of Wikipedia. Okay, dear students, actually in this case we will have to convert kilometer into meter, then speed will be in meter per second. Actually here conservation of angular momentum is the key concept which helps us in solving this problem. Okay, so we are now going to its solution, but before starting its solution in a formal manner, we have to go through a few concepts with the help of snapshots taken from some books. Okay, first snapshot is about linear momentum. Okay, the linear momentum P vector of a particle of mass m moving with velocity v vector is P vector is defined as mv vector. Okay, here three lines. It is sometimes read as equivalent to, sometimes read as equal to, and sometimes read as is defined as. Okay, so this is linear momentum. Next we are going towards angular momentum. Okay, the angular momentum L vector about an axis through the origin of a particle having linear momentum P vector equal to mv vector is L vector is defined as R vector product P vector. Okay, R cross P. Cross product or vector product of R and P, where R vector is the vector position of the particle relative to the origin. Okay, this is about angular momentum. Next snapshot is about quantization of angular momentum. Okay, so this snapshot is not very much related to this problem. Anyhow, as we are dealing with angular momentum, so we must have some idea about quantization of angular momentum. Okay, irrespective of whether this expression is going to be used in this problem or not. Okay, quantization of angular momentum. Ln is equal to mvn rn, where n is written as a subscript of v and r. Here Ln is orbital angular momentum, m is the electron mass, Vn is electron speed, and Rn is electron orbital radius. This alternatively becomes equal to n h over 2 pi, where n is the principal quantum number, n equal to 1, 2, 3 and so on. H is Planck's constant. Okay, and pi, we know that 22/7, 3 in decimal representation it is taken as 3.14 up to 2 decimal places. Pi has a very strange sense in mathematics. Its decimal representation is non-repeating, non-terminating. It goes endlessly. Okay, it is very surprising. How is it possible that it goes endlessly? It has no end. Its decimal representation changes itself regularly, and its decimal representation is non-repeating, non-terminating. It goes endlessly. Okay. Now we come towards the meaning of the term apogee. Apogee is the point in the orbit of an object, such as a satellite orbiting the Earth, that is at the greatest distance from the center of the Earth, or the point farthest from a planet or a satellite, such as the moon, reached by an object orbiting it. Okay, so meaning of this term has been included in this problem. Okay, now perigee. Perigee, the point in the orbit of an object such as a satellite orbiting the Earth that is nearest to the center of the Earth. Or alternate sense is the point nearest a planet or a satellite such as the moon, reached by an object orbiting it. Okay. Dear student, now we are going to solve this problem in a regular manner, formal manner. And as I have told already that here conservation of angular momentum is the key concept. We know that we have seen here from previous slides that angular momentum is mvr. Here we are applying conservation of angular momentum. So angular momentum in case of perigee and angular momentum in case of apogee, both are equal. Okay, according to conservation of angular momentum, we have mvr is equal to mvr. Okay, first mvr in case of apogee and second mvr in case of perigee. Okay, here we do not put any value of m, so m will be cancelled on both sides in next step. Okay, so m into v, speed of apogee is to be determined, so we will not put any value in place of this v. Okay, this v will remain as it is. However, in place of r we have put the value given in the statement, which is 42,200 kilometer, but that is the value of diameter. Here we are going to use radius, so we will divide it by 2. Okay, now we go towards the parallel side with perigee. In case of perigee, again we have not put any value in place of m. Okay, so m will be cancelled on both sides. Next, here v for perigee case is given as 10160 meter per second. Okay, this is the speed of perigee case. Next, r radius, which is the half of the diameter, is also given in the statement. Okay, 6680 by 2 kilometer. Okay, so this implies that in the next step m is cancelled by m. Okay, why, dear students? Next m is meter, but this first m is mass. Okay, m is cancelled with m. However, m used in speed as meter per second or radius in a kilometer still exists. Okay, this implies that v into 42200, we have increased three zeros because we have converted kilometer into meter. Okay, divided by 2, this is equal to 10160 meter per second into 6680. Here again we have increased three zeros because we have converted kilometer into meter, divided by 2. Okay, radius means half of the diameter. Now this implies that v becomes equal to this. Just simplification. Okay, we will not discuss these simplification steps. Okay, meter inverse will be cancelled with meter. 1 meter, there are 2 meters in the numerator while 1 meter is in the denominator, so 1 m will be cancelled with the m of the denominator while 1 m will still exist. Okay, hence speed v becomes equal to 1608.26 meter per second. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.